In this video, I want to give you an introduction to immunology. So what is the immune system all about? The immune system is about to kill the pathogen without harming the host. So the immune system is a collection of cells, tissues, and molecules that mediate resistance to infection. So we are constantly threatened by pathogens. We can breathe them in through the air, we can eat them on a sandwich and they try to invade us. But fortunately we have the immune system. And the immune system has a job of destroying the pathogen. Now, immunology is challenging and it's complicated because the immune system acts as a team. So it's not one single cell that does a job. And therefore, if you're studying immunology, you also need to make sure that you always keep up with the big picture. It's kind of the same scenario if you would watch a baseball game and the cameraman would only kind of follow one player. The whole game would not make any sense to you. So you always want to make sure that you don't only follow one cell, so that you really know what this cell is rather doing to the contribution of destroying the pathogen and how it kind of interacts with other cells. Now, you probably know that the immune system can be split up into two parts. There's an innate and an adaptive part. The innate immune system is a part that all animals just naturally seem to have. So this is our first line response. This is our low-tech system that is immediately ready to fight. It's kind of quick and dirty because it's immediately ready to destroy pathogens, but it's dirty in a way because it cannot tell us any specifics. It can just say, oh, there's something invaded us. That's probably a bacteria or that's probably a virus, but it cannot tell any specifics. It cannot say that's Salmonella or that's Escherichia coli. So it just recognizes generally pathogen classes, but it's ready immediately. It's absolutely necessary, and we're going to get back to this in a couple of minutes, and it does not have any memory. So if the same invader comes back kind of 2 years later, the innate guys will do exactly the same thing. They will not be any faster, not be any more efficient. Now, in contrast, we have this adaptive immune system. It's adaptive, and as the name already implies, because it can adapt to possible any invader. These are the specialists. That means the specialists are the experts. And as in real life, experts always require time. They have memory, so they can remember things. And the second time you're invaded by a specific pathogen, they will react way faster. They also can be potentially dangerous. So when we said in the beginning, the immune system should kill the pathogen without harming the host, we all know that things can go wrong. We can develop autoimmune diseases. Most of the time, the adaptive guys do something wrong, and that can be potentially dangerous. So now I also want to introduce the key players of the innate versus the adaptive immune system. So the key players of the innate immune system are macrophages, neutrophils, dendritic cells, monocytes. Monocytes are actually the precursor of macrophages, eosinophils, which are particularly important for getting rid of bigger stuff like worms, and the natural killer cell. And then on the adaptive side, we have two cells, the T and the B cells. Now we can also ask ourselves, where are they coming from? Well, they're all made in the bone marrow and they come from different lineages. So most of the innate guy are originating from the so-called myelin lineage. And all the adaptive cells are made via the lymphoid lineage, so they have a lymphoid progenitor. And the NK cells are kind of the exception because these are cells from the innate immune system, so they're ready to fight. They don't need any extra activation or extra training like the specialists do, but however, they come from the lymphoid lineage. So they come from the same progenitor that gives rise to the T and B cells. So I want to now explain also a little bit about why the innate immune system is absolutely necessary. So let's look at a timeline of an immune response. So let's suppose you're exposed to a pathogen and you're seeing this pathogen the first time. So we have a first exposure. Now, if you would not have any immune system, there's nothing kind of to fight this infection, and death would be a possible scenario. But normally, when we have an immune system, the innate immune system is going to kick in because we said these are the cells and molecules that are immediately ready to fight. So within minutes to hours, the innate immune system is going to kick in and try to clear the infection. So if this is a very mild infection, it might be possible that the innate immune system alone can clear the infection, and this would be the outcome. But let's say it's not enough. They cannot get rid of the pathogen. So what are the options here? Now, the innate immune system is a part of the immune system that will get us the experts. And that now explains why the innate immune system is absolutely necessary. Because without innate immune system, we're not even going to get the experts. So the innate immune system can get the expert. It takes about a week to get them. Then they're going to make their weapons. They're going to get activated, and then they need to bring the weapons back to the site of infection, and then hopefully they can help to clear the infection. If things go wrong, well, then death is still a possible scenario. So now I want to finish up with talking a little bit about where are things happening, and also introducing the terminology of primary versus secondary lymphoid tissues, so what that means. Now, first of all, let's ask a question: where are immune cells made? So all immune cells are made in the bone marrow. And as we already said, the cells of the innate immune system are made in the bone marrow and then are stationed throughout our tissues, are ready to fight, so they don't need any extra kind of training. However, the cells of the adaptive immune system are experts, are specialists. They actually require some additional training, some additional education. And this additional training happens for the B cells in the bone marrow, B for bone marrow. And for the T cells, it happens in the thymus, T for thymus. So now we can summarize and can say, well, the bone marrow and the thymus are the organs or the tissues where immune cells are made, which would imply for all the innate guys, and or educated, because as we said, the adaptive guys need some extra stuff. They need some extra training. So the bone marrow and thymus, we call them now primary lymphoid tissues, because that's where the immune cells are made and or educated. The adaptive immune cells, once they got their specific training, their specific education, they are still not ready to fight. They need to become activated. And this happens in the so-called secondary lymphoid tissues. So once they are made and educated, they will recirculate in so-called secondary lymphoid tissues. This means they're going to hang out either in lymph nodes or in the spleen, or in so-called mucosa-associated lymphoid tissue, which is abbreviated as MALT, and wait if they get activated. If they get activated, they will produce their weapons, and then the weapons are going to be brought back to the site of infection. But we can now summarize and say these tissues, we can call them secondary lymphoid tissues, because these are the sites of adaptive immune responses. These are the sites where the adaptive cells get activated. So now let's just put this all into perspective and say, okay, we're going to hit a nail in our big toe. So bacteria are going to be sticking on this nail and are going to be introduced into deeper tissue here in our feet. So what's going to happen now in the feet? Well, we have our innate cells, which are stationed throughout the body. So these innate cells are going to fight this infection. They are ready to go immediately. If they can clear the infection, fine, then we're done. But if they can't, they need to go. In particular, one cell that we're going to discuss in a minute, the dendritic cell, they need to go to the nearby lymph node, see if they can find a cell an adaptive cell that they can activate. The weapons are going to be produced and they're going to be brought back to the feet. So that's how you can think about the geography of the immune system. And always when we discuss stuff happening and where things are activated, you always need to ask yourself, where are we? Because it's the primary site of infection where only the innate cells are going to be stationed in the beginning. And then somebody needs to get help. Somebody needs to travel to the next nearby lymph node, produces weapons of the adaptive immune system, and then these weapons need to be getting back to the site of infection. This concludes the video on a general introduction to immunology.